guys, and welcome back to the ACE Academy. In this video, we will be looking at equivalent resistance. Now, equivalent resistance is essentially what we do when we want to replace a system of resistors or a collection of resistors by a single resistor in order to replace it in the circuit and so that it can have the same effect. This can be done quite simply using a certain set of rules. We are going to start off by looking at how to calculate the equivalent resistance of a simple series connection. Now, looking at your screen right now, we can see that all we would have to do in order to calculate the equivalent resistance of a set or collection of series resistors is simply add up the resistance values. Let's go ahead and do a couple examples together. In the case of the first example, we can see we have two resistors connected in series. R1 has a resistance value of 3 ohms and R2 has a resistance value of 5 ohms. If I wanted to calculate the equivalent resistance or the total resistance of this connection, I could simply use the formula RT is equal to R1 plus R2, and that would be equal to 3 plus 5, which is equal to 8 ohms. So what I've done here is I have essentially said that if I replace this system of two resistors, one with the value of 3 ohms and the other with the value of 5 ohms, by a single resistor with the value of 8 ohms, it would not affect my circuit. It has the exact same effect as this connection right here. Let's go ahead and do a couple more examples. For the second example, applying the same rules, I would get RT is equal to R1 plus R2 plus R3, which is equal to 2 plus 7 plus 1, which is equal to 10 ohms. In this case, if I replace this collection of 3 resistors with a single resistance value of 10 ohms, it will not affect the way my circuit works. Looking at example 3, I have two resistors, a collection of 2 resistors. Applying the same rule, I would get RT is equal to R1 plus R2, which is equal to 10 plus 5, which is equal to 15 ohms. Exact same thing again, replacing those two resistors with a single resistor of the value 15 ohms will not change the way in which my circuit works. It's quite simple, guys. I don't think we have to dwell too much on this part of equivalent resistance. We are now going to move on to equivalent resistance of resistors in parallel. Now, when it comes to the equivalent resistance of a system of resistors in parallel, it becomes a bit more tricky. We now have to use the formula 1 over RT parallel is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc. That's how it would work now. Now, this formula is a bit complicated if you haven't used it before, so I'm going to go ahead and do a couple examples with you guys and show you how to use this formula. In the case of the first example, we can see that we have two resistors, one of the value 2 ohms and the second of the value 4 ohms, and these resistors are connected in parallel. Now, if I wanted to find the equivalent resistance of the system, it would simply be 1 over RT parallel, and RT parallel is in fact the equivalent resistance of this parallel connection, is equal to 1 over R1 plus 1 over R2. If I substitute in my values, I would get 1 over 2 plus 1 over 4, which is actually equal to 3 over 4. Now 3 over 4 is equal to 1 over RT parallel. But I want RT parallel. So all I would do is invert this answer. I would get RT parallel is equal to 4 over 3 ohms. And I have officially found the equivalent resistance of this parallel connection. What this means is that if I replace this parallel connection with a resistor of the value 4 over 3, it would not change the way my circuit operates. Let's look at the second example. In the second example, I have a collection of 3 resistors all connected in parallel. I could then apply my formula and I would get 1 over RT parallel is equal to 1 over 3 plus 1 over 6 plus 1 over 9. I would get 1 over RT parallel is equal to 11 over 18. And again, I'm finding RT parallel and not 1 over RT parallel. So in order for me to do that, I would invert my fraction and I would get RT parallel is equal to 18 over 11, which is in fact equal to 1.63 ohms. This means that if I had to replace this parallel connection with a single resistor of 1.63 ohms, it will not affect the way my circuit operates. Looking at the third example, I have a collection of 4 resistors in parallel. Let's go ahead and calculate what the equivalent resistance of this connection would be. I would obtain 1 over RT parallel is equal to 1 over 2 plus 1 over 2 plus 1 over 4 plus 1 over 4. And that would be equal to 3 over 2. So I know that 1 over RT parallel is equal to 3 over 2. That means RT parallel is equal to 2 over 3, which is equal to 0.6. 0.67 rather. So simply, if I were to replace this entire parallel connection with a single resistor of the value 0.67, my circuit would operate as normal. Now I want you guys to notice one more point. The equivalent resistance of a parallel connection is always less than the highest value of a resistor in the connection itself. 4 divided by 3 is less than the value of 4 in this connection. 1.63 is less than the value of 9 in this connection. 0.67 is less than the value of 4 in this connection. That means that if we are using a parallel connection of resistors, we are lowering the resistance in the circuit instead of increasing the resistors in the circuit. That means that the more resistors I have in parallel, I would decrease the resistance in the circuit. It's quite a simple concept, guys. It is a bit tricky. I want you guys to focus. Just go through what I did again if you need to. But I would assume that with enough practice, you guys would be able to find this part or this application a bit easier. Okay, now this is the final part of this video, and it is perhaps the most important application of these rules to finding equivalent resistance. Here we have a collection of resistors. We have 2 resistors in parallel and a single resistor connected to it in series. How would we find the equivalent resistance of this connection? It's quite simple. We know that the equivalent resistance of a parallel connection is essentially the same as me saying I am replacing this parallel connection with a single resistor value that has the same effect on the circuit. So the way in which I would do this is I would find the equivalent resistance of the parallel connection first. Let's go ahead and do that together. 1 over RT parallel is equal to 1 over 2 plus 1 over 2, which is equal to 1 over 1. RT parallel will therefore be equal to 1 ohm. So I could simply redraw this connection as a resistor of 1 ohm in series with a resistor of 2.5 ohms. And now I simply have a series connection for me to find the equivalent resistance of. And we know that when we have a series collection of resistors, we simply add up their resistance. So the total resistance of this connection is actually 1 ohm plus 2.5 ohms, which is 3.5 ohms. Now, if I wanted to do this neatly in one step, I would simply say RT is equal to RT parallel plus R series, where RT parallel is the equivalent resistance of my parallel connection and R series is my resistor in series. It's quite simple, guys. Please practice this. This is extremely important. It will be in your paper and it's quite simple once you get the hang of it. All the best, guys. That's it from me, and I will see you in the next one.